4.1F is about applications of systems of linear equations. So we're going to take our three methods, solving by graphing, elimination, and substitution, and we are going to use them to solve word problems. So two things we've done before this year, we're just going to smush them together. So there are three different types of situations, and the only thing that really changes is how you set up the initial equations. So for all of these, we're going to need two equations in order to solve them, right? Because we're going to use one of those three methods, graphing, elimination, or substitution. So let's look at how much of each type. So how much of each type? Katie has 70 coins of nickels and quarters in her piggy bank that total $13.90. And we want to figure out, well, how many of each coin does Katie have? Okay, so how much of each type? Essentially, we're trying to figure out how many nickels does Katie have and how many quarters. And so that's how we define our variables. We let X be the number of nickels and Y be the number of quarters. So remember, since it's a system of equations, we're going to set up two equations. We know that Katie has 70 coins. So if we take all of the nickels Katie has and all of the quarters Katie has, it should equal 70. That's the first equation, right? How much of each type? If we add them together, we should get 70. Okay, well, think about how much a nickel is worth. A nickel is worth 5 cents. Okay, and a quarter is worth 25 cents. So if we take the amount of money our nickels add up to and the amount of money our quarters add up to, they should equal a total of $13.90. Notice how I'm making sure to have my decimal, right? So since we're talking about cents, we need to remember it's not 5x, it's 0.5x, because that's how many cents a nickel is worth. Now we have these two different equations. We have our system, so we are ready to solve, and we can use elimination, graphing, or substitution. Well, I'm going to use elimination, so let's go ahead and eliminate our x's or y's. Let's say we eliminate our x's, so we'll multiply by negative 0.05. Okay, so let's look at what we have now. We've got negative 0.05x minus 0.5y equals, well, 70 times negative 0.05 is negative 3.5. Okay, remember when you are eliminating, you need to take whatever you're multiplying by, so our negative 0.05, and we multiply it by all three terms in that equation. Our bottom equation is going to stay the same. All right, and then we just need to combine. So this would be a good time to take a second and see if you can finish solving this for yourself. Okay, so hopefully you were able to solve this, but let's double check your work. When we combine or add our two equations together, we're going to get 0.20y equals 10.4. Remember, since it's elimination, we wanted those x's to eliminate, so they add together to equal 0. But when we take our 0.20y and we divide, we're going to find that y equals 52. So putting that in the context of our problem, right now we know that we're going to have 52 quarters. Well, we've got this handy-dandy equation we can plug it into. So we could take x plus 52 equals 70. We could plug it into the other one, but in my opinion, this one is much simpler to figure out. X is equal to 18. So now that we've figured this out, we need to write our answer in a sentence. So we know that Katie has 18 nickels and 52 quarters. And that's our final answer. All right, just to put all this in perspective for you, it seems like a lot of work, but the only new thing here is setting up these equations. So this is the only new thing. And we've actually done this before this year where we've set up equations. So we're just taking our previous knowledge of setting up equations and combining it with our knowledge for solving systems. So just keep that in mind that you've done both of these skills before. We're just putting them together right now. Let's look at a problem where we're comparing two things. When you compare two things, we need an equation for each thing. So we're trying to figure out which catering company would be the best for the party. So company A charges $100 plus $3 per person. Company B charges $60 plus $5 per person. And we want to figure out after how many people will the cost be the same price. So we don't know the people, so let's let X equal the people. And we don't know how much it's going to cost. So let's let Y equal the cost. So again, since it's comparing two things, well, it seems like we're comparing company A and company B. So we're going to let one equation be company A and one equation would be company B. Okay, well, the cost for company A is going to be $100 plus $3 per person. So since X represents our people, that's going to be 3X plus 100. This would be a good time to pause and try to set up the second equation. Well, the cost for company B is going to be Y, and we know we have to charge pay $60 plus $5 per person. So we'll have 5X plus 60. Okay, now that we have our equation set up, we just need to solve. So again, pick graphing, elimination, or substitution. This would be a good time to pause the video and see if you can solve it. I'm going to use substitution just because I think it's set up really nicely for that. So again, hopefully you were able to solve this, but let's just double check our work. Right now, I'm just going to get my like terms on either side. So I'm moving my x's, I'm getting my whole numbers on the other side. So 100 minus 60 leaves us with 40. 5x minus 3x leaves us with 2x. And when we divide, we find that 20 equals x. So we know after 20 people, they're both going to cost the same. So we can take that 20 and plug it into either of these equations. I'm going to pick the top one just because. 3 times 20 plus 100 leaves us with 60 plus 100, so 160. So putting that into the context of our problem, our final answer is after 20 people, both companies cost $160. So again, just putting this into context, all that's different in this one is our equation setup was a little different. Since we were comparing two things, we had an equation for each thing we were talking about. Last but not least, we have two situations. So again, since there are two situations we're talking about, we're going to have an equation for each situation. So our problem, the State Fair is a popular field trip destination. This year, High School A and High School B are going there. So we have information about High School A. They rented and filled 8 vans and 8 buses with a total of 240 students. High School B rented and filled 4 vans and 1 bus with a total of 54 students. So we know that every van had the same number of students in it, and the buses had the same number of students. So we want to figure out the number of students in each van and in each bus. So that last part, that's what we're trying to find. That's our unknown. We don't know how many students are in each van and each bus. So that's how we define our X and our Y. Well, two situations, we're talking about High School A and High School B. So those are our two different situations. You just need to write an equation. Well, High School A says 8 vans, so we have 8x if we take the number of vans times the number of people in each van. Okay, that's where we get our 8x from. And we add 8y, so the number of buses times the number of people in each bus. That should equal that total of 240 students who went on the trip. This would be a good time to pause, try and write the equation for School B. Well, it's really similar, but they have 4 vans, so 4 times x, plus 1 bus, so 1 times y, and they had a total of 54 students who went. These are our two equations, so again, all we need to do is solve. So elimination, substitution, graphing, whatever you want. I'm going to go with elimination just because how it's set up. I'm going to eliminate my x's, so I'm going to multiply this bottom equation by -2. Well, 8x plus 8y equals 240. Again, maybe you want to pause, try and solve this for yourself, and then check your work. Remember to multiply every single term by that -2. So 4 times -2 is -8x minus 2y equals -108. And all we need to do now is add our equations together and see what we get. Well, our x's eliminate. That's exactly what we're looking for. 8y minus 2y is 6y. 240 minus 108 leaves us with 132. Divide both sides by 6. Well, y is equal to 22. So that tells us that there are 22 people per bus. We're going to take 22, plug it into one of our equations. Doesn't matter which one. I'm going to pick the bottom one just because it seems a little simpler. So 4x plus 22 equals 54. Go ahead and finish solving for this. 4x equals 32. Well, 32 divided by 4 tells us that 8 people fit in each van. So last but not least, just write this as a complete sentence. That leaves us with there are 8 students per van and 22 students per bus. And we're done. So make sure you show all your work by writing both equations. Remember, we're solving using systems of equations, so you need to have the equations. The 3 different types that we looked at, all that's different or all that changes is that initial setup of your equations. Your equations will look a little bit different. All right. Remember to answer the questions at the bottom and then hit submit.